In this video, we're going to look at measurement error. Measurement error is a type of systematic error. So when we talk about error, we're talking about the fact that we collect information from a sample, a smaller group from the population, and we're trying to make inferences, being able to make statements about the greater population, the greater group. But error comes from when we go to make that statement about the greater group, it's not accurate about the greater group. So that can exist because we have sample design error. So when we go to select the smaller group from that population, maybe we've incorrectly defined the population, so population specification error. Maybe we have frame error, which is then the sampling frame, the list or the group that we think represents the population that we're pulling people from. Maybe it doesn't actually represent the population, so there's a problem with our source that we're getting our sample from. Or maybe we have selection error in terms of our procedure for pulling our sample from that frame is not truly random, and so we're excluding groups in that selection. So one source of error is that sample design error, and that's in how you collect your participants. In this particular video, we're going to look at measurement error. Measurement error comes from the tools you're using not giving you the information that you're after. Okay? There is a third type of error, which is the random error. And random error comes from, overly optimistic, overly pessimistic, unique things to individuals that might be situational, and that can be resolved with having a large sample size. So let's focus in this video on measurement error. Those measurement tools, are they giving us what we are expecting to collect in terms of information? So when it comes to measurement error, we have processing error, response bias, non-response bias, measurement instrument bias, interview error, which we've talked a bit about before, and surrogate information error. So let's go through this list. So let's start first by creating a formal definition of measurement error. And so measurement error is a systematic error. Okay, where did I go? Systematic error that results from variations between info that is sought and what is actually obtained. So the first example of that is surrogate information error. Surrogate information error is an error that results from a discrepancy between the info that's needed to solve a problem and what is being sought by the researcher. So in other words, the data that is being collected doesn't actually help solve the management decision problem. We need to put that higher up. There we go. So in order to fix this, we need to make sure as we create our questionnaire that each question we're asking ties back to a research objective, that all the research objectives have corresponding questions, paying close attention to the type of information that is needed to have the organization take action, make a decision, and making sure that information is what's being collected. An example of surrogate information error was in 1999, Kellogg developed 17 breakfast cereals that featured ingredients to help cut cholesterol. Now, the problem is that these cereals did not sell. Yes, people wanted to lower their cholesterol, but they didn't want to do it with breakfast cereal. And so by not having clear information in terms of what we are looking at and the decision that would be made, then we're asking the wrong questions here. And here we're trying to sell low cholesterol cereal when, yes, people were interested in lowering their cholesterol, but their concern wasn't what they were eating for breakfast when they were looking at a low cholesterol diet. So we want to make sure we are addressing and we have information that will aid in the decision that the business is looking to make. The next type of measurement error we want to consider is interview error, and we've talked about this one before. Interview error is an error that results from interviewers, the researchers, influencing, and this could be consciously or unconsciously, the answers of the respondents. This could be that the way that the questions are phrased, the tone that's used by the interviewer. This could be a desire by the respondent to please the person who is asking the questions, or the behaviors, the mannerisms of the interviewer are turning off respondents, and so they're more likely to be negative in their responses. How do you deal with this? Well, you train your interviewers and we monitor them. So one of the reasons the telephone interview gained popularity is that it could record the interviews and it could be used to improve the quality and provide guidelines for interviewers in terms of what to say and how to act. And then go even further where computers are telling the interviewers which question to ask, which words to use to help in terms of reducing that bias, that amount of influence that the interviewer is having on the respondent. Another way to deal with interviewer error is to use more of a self-administered or an online survey where there is no interviewer at all. The next type of measurement error is measurement instrument bias. This is an error that results from the incorrect transfer of info from a survey to, let's say, a computer or spreadsheet. So transcription error here. Essentially, if we are taking surveys that people filled out by hand and we are then coding them, if we code them incorrectly, if we are writing down incorrectly the responses, then we have measurement instrument bias. And that's not the right definition at all. Let's try that again. That's because that's processing error, is a transcription error. Wait a second, this doesn't make any sense. Okay, measurement instrument bias. Let's try this again. This is error from the design of the questionnaire. Or the measurement instrument we're using. So this is where we were talking about reliability and validity before. Making sure in the wording of our questions, the type of measurement scale we're using, that it's appropriate for the information we need. So one of the ways to help address this, to make sure that we are getting consistent data so it is reliable and that it's valid, that we are actually getting it to measure what we want it to measure, is to have people test it, complete the questions, and look at the feedback we get. Does that actually tie to our research objectives and the decisions we're trying to make? Are we getting the types of responses we expect to get? Have we offered all of the options for the multiple choice questions? So if we're looking at measurement instrument bias, we need to do things like avoid leading questions, Use balanced scales if we're measuring attitudes and we don't have a reason to have it shift one way or the other. Watch those words that we should be avoiding. This example here says, in your opinion, is marketing research the best business course you've ever taken? Or is there another less valuable course you would consider to be the best? So notice the biased wording here. There's some other less valuable course. That's very loaded language. Notice that it's a very convoluted question, right? Is this the best business course you've ever taken? Or is there another one? And then notice the word best, right? We want to stay away from some of that language like that, which can be the extremes. So going back to the videos where we discussed reliability and validity, words to avoid, and how to structure your questions, that's the measurement instrument bias. All right. Now let's write the definition I was trying to give earlier, which is the transcription error. And this is the error that results from incorrect transfer of info from the survey to our computer, whatever database, Excel spreadsheet. So this is transcription error. This is error in terms of typing it up so that we can analyze it, or error in our coding when we convert responses to numbers to make the analysis easier. So how do you fix this? Well, we want to minimize the number of times the data is transcribed. One of the benefits of an online survey is that no transcription is required. It auto dumps it into an Excel or a CSV file. The challenge with paper surveys, of course, is that somebody has to enter all that in to do the analysis. The other thing we do as we clean our data, so prepping it for analysis, is we check for outliers. Are there any responses that don't make any sense? So we ask what people's ages are, and they give us 99. Is there a 99-year-old in your sample? When you ask how many years people have been with the company and they say 70, has there really been people who've been with the company for 70 years? Maybe the company hasn't even been around that long, in which case we automatically know that's an incorrect number and we remove that particular response, not everything that person provided, but that particular one that we know that that number is not correct. We don't replace it with something else because we don't know what the true information is, especially if it's anonymous, but we do know that their age is not 99 or their years of the company is not 70 if those aren't possible given the pool of respondents. So in our cleaning process, we will deal with that processing error. We're checking for accuracy and we're looking for outliers. And we're looking for things like, does it match the skip pattern? If they answered the question when they were supposed to skip it, that could be a transcription error, or it could be an error by the original participant. Okay. We want to reduce the amount of transcription, the amount of times it has to be retyped up as much as possible. Then we have the next one is non-response bias. Non-response bias is an error. Got too many R's there. An error that results from a systematic difference between those who do not and those who do respond to a particular question or to the survey in general, to a measurement instrument. So what we would like it to be is that if we don't have 100% response rate, which we won't, everyone we give our survey to won't complete it, we would like it to be that those who choose not to complete it, it's essentially at random, which means those who do respond, we get a representation from the population, all the different groups, whether that's different ages, different geographic regions, different interests. We get a representation of the greater population. We have a problem, though, if the group who does not respond, who skips a question, or the group who doesn't respond to the survey at all if they all share some common characteristics. Because then the problem is that we are missing an important cohort of individuals. So we need to figure out how to get the greater group to respond. So how do we get a higher response rate and a lower non-response bias? We have shorter surveys, we do multiple contacts, we create incentives. We're trying to encourage more people to participate. So our concern with a non-response bias is it means we no longer have a representative sample. It no longer represents the population as a whole. Now, the higher the response rate, the less likely there is a non-response bias. So we need to be able to calculate what our response rate is. So how do you calculate a response rate? Well, a response rate is the number of completed interviews or surveys divided by the number of eligible responding units in the sample. So for example, with a mail survey, so you sent it through snail mail, how many usable questionnaires were returned versus the number of contacts attempted minus the number of bad addresses. So we look at how many of these mail items we sent out, but we do subtract from that the ones that came right back. So for example, let's suppose that we had 1,000 randomly selected individuals to respond to our survey. And when we sent 1,000 snail mail packages out, maybe what we found is that 58 of them came back. So we don't count those because that didn't actually get to somebody. And let's say from that, maybe we got 202 at least partially created or completed questionnaires. So our response rate then is the 202 divided by our 1,000 minus 58. And so we're doing that calculation there. We end up with a response rate that is about 21%. Okay. So, and you can't see that because my head is covering that. So 21% there. So we consider any survey that's more than half filled out to be a completed survey. And again, we don't count any of the surveys that we know did not come in contact with people. So anything that was auto-returned, the address didn't go to that sender, then that is not included. When we look at, for example, telephone surveys where there's no eligibility requirements, so we don't have to screen to see if a certain person has the prerequisite knowledge to respond to the survey. So it's just the people at home we get in contact with. Then we would take the number of completed interviews divided by those number of interviews plus the number of people who refused to complete our interview. So we talked to them, but they weren't willing to do the interview, plus the number that were not at home. So suppose, for example, that we selected 200 names from a phone book or from a list of people. And from that, let's suppose that 112 completed the interview. Okay. And remember, we were trying to contact 200 people in total. We find that 27 people refused to participate in our interview. And 57, we try to call multiple times, but we get no response. Maybe they're screening our calls. So there were 57 who we called 3 times, and all 3 times we got no one picking up. Now, in that total 200, because you'll notice those 3 numbers don't add up to 200, the other ones we called, that phone number was no longer in service. So we don't include the ones that are no longer in service in our calculation. So we talked to 112 people. That 112 plus the 27 who refused plus the 57 who didn't pick up the phone gives us a response rate about 57%. Okay. So you can see how we're calculating that response rate in terms of the number of at least partially completed surveys or interviews divided by the number of people that we were actually able to get in contact with at least partially, and maybe they chose to do the survey, maybe they refused to do the survey, or maybe we know that they were there because it went to the right address, or it went to a home phone number that was in use. But we're assuming because they didn't get back to us or pick up the phone that they are in part of that refusal group. And so we can calculate the response rate. We can also calculate a response rate. What if there is an eligibility requirement? So what if when you make your phone calls, for example, that there are only a certain percentage of the people that you phone who would pass that screen question, who would have the relevant knowledge you're looking for. So then the calculation gets a little bit more complicated because we need to take into consideration that not everyone we're trying to contact is eligible. So let's suppose that we have 338 who completed interviews. We have 89 who refused to do our survey. We had 169 who were not at home. We had 292 who weren't eligible, so they didn't qualify with that screen question to have the knowledge we're looking for. And 112 people had numbers that weren't in service or didn't get us to the people we were looking for. So we would start by finding the eligibility percentage. So the percentage is the number of completed interviews, which was our 338, and the number of completed interviews here, plus the number that are ineligible. So we got a hold of those ineligible people, that 292, and they answered at least the first question, but it turned out they didn't have the information, the knowledge we needed. So our eligibility here is 338 divided by 338 plus 292. So our eligibility percentage is 54%. So now we're looking at the response rate. We would look at the number who completed the interview, 338. We would have our 54%. 338 plus our 54%, and that 54% is going to be times the number of refusals and the number of not at home, because we're assuming that everyone who refused isn't eligible. And so we really only want to consider that percentage of the refusals that would have been able to answer our survey and would have had the knowledge, but they chose not to. So we take that 54% and apply it to the number of refusals, which here was 89, and the number not at home, because if we had gotten into contact to everyone who was not at home, we still wouldn't have gotten information from every single one of them, because only about 54% would have had the relevant knowledge. So then we would add here the 169. So 89 plus 169, and we multiply that times 54%, add it to 338, take 338 divided by that, and we get, in this case, a response rate about 71%. So we are adjusting for the fact that not everybody who could have talked to us, who refused or didn't pick up the phone, really would have been relevant to us. So you want to be able to calculate and report your response rate. Oftentimes in a email online survey, it's simply we sent it out to 100 people and we got 30 responses. We got a 30% response rate. You can make these adjustments if there are concerns that some of the email addresses bounce back, or if you're not going to, if some of the people you contact wouldn't make it past your screen question. So you can see those adjustments here. Now we're talking about non-response bias, right? The key concern is that it's no longer representative of the population, and there's a key group or certain characteristics from the population that are not being represented. So we're concerned about that non-representative sample. When it comes to surveys in Canada, the refusal rate of surveys is around 64%, so there is a high refusal rate. We did say about half of Canadians do complete at least one survey per year. But as we move more to smartphones, we no longer have phone books. We no longer have lists of contact information. People don't answer the door. People don't answer the phone. We are less and less likely to participate in these. And so the refusal rate goes up. The challenge we have is that there are certain groups who are more likely to refuse than others. And this is what creates that non-response bias. So people who've had an unpleasant research experience in the past, people with older children, people who are more educated, people who themselves are younger. Interestingly, people who live in BC and Quebec are less likely to participate in research and surveys than other provinces. People who live in small cities are less likely to participate than people in bigger towns, bigger cities. And people who prefer to speak French instead of those who prefer to speak English, people who prefer to speak French are less likely to participate in surveys. So you need to recognize that this will impact your ability to represent your population. If your population of interest is multiple provinces, you're going to be missing the BC Quebec people from your sample. If your population is English and French speakers, you're not going to have as many French speakers in your sample. If your population is younger people in their late or their early 20s, they're going to be much harder to get information from. And so the decisions that you make, the extrapolations you make to the bigger population are going to be missing their perspectives. And so that's important to recognize. The other thing is to recognize that we're looking at not only certain groups having higher refusal rates, but also as you're trying to collect the information, when are you asking for this information? Are there certain groups who aren't available at certain times or aren't available through certain methods? Can you, in terms of your sampling procedure and in terms of the measurement instrument, the type of survey, the type of research design you're using, does that increase your response? Here, this is an interesting graph. It shows you the refusal rate. We random digit dial, so we just randomly generate phone numbers and dial them. The response rate before smartphones and before texting was already sitting at close to 50%. And today that refusal rate can be as high as 93% in a world of where people don't answer their phones and only do texts. Then the challenge becomes, if your refusal rate is 93%, then you send out 100 surveys, you get 7 responses. Right? Which means to get a big enough sample to make some decisions for your organization, you're then sending out thousands of surveys to just get a small group in. And that's why trying to increase the response rate is so important. Which brings us to what if they do respond, but there is bias in the response? So the last type of measurement error we want to look at here is response bias. This is an error that results from the tendency of people, to answer a question in a certain way through either deliberate falsification or unconscious misrepresentation. So if it is unconscious misrepresentation, so the answers they're giving in their responses are not true, but it's because there's a misunderstanding. That can be because of the way you worded the question, the formatting, the order of the questions that creates confusion. So if it's unconscious misrepresentation that's causing your response bias, you can resolve this by doing a pretest of your questionnaire, by double checking that you are not creating double-barreled questions, that you're avoiding the words we told you to avoid, and making sure we're clear and concise. But if we have deliberate falsification, if the people responding to your survey are intentionally misleading you, then the question becomes why? What is creating that response bias? Perhaps they want to appear more intelligent than they are. Perhaps they don't want to reveal information that is embarrassing to them. Perhaps they want to conceal or hide information they feel might cause them to be recognized in the responses. And so this comes back to, are you providing a way for people to respond honestly? Is it anonymous? Is it confidential? Are we using, for example, projective tests and third-party techniques so that people can disclose more embarrassing information without it having to be about them personally? They can put it on to someone else or people in general or a group in general. That helps then allow for them to be more honest in their responses. The other thing we can do to reduce this response error where there's deliberate falsification is to make sure that people who are completing the survey have the knowledge to complete the survey. So using screens and skip questions so that those who don't have that information, haven't had that experience, haven't used that product, don't have to answer questions they don't know anything about. And so you can also then, for your attitude scale questions, have a not applicable or have an I don't know option where people who don't have the information don't have to provide an opinion or perspective when they don't actually have one. So when we're looking at our measurement error, this is the difference between what we were attempting to collect in terms of data and information and what we actually gained. We want to avoid response bias. So we want it to accurately reflect how people actually feel. It's not falsification or misrepresentation. We want to have a low non-response bias. So if people are not responding, if we have a higher refusal rate, we want those people who are refusing to be somewhat random, in which case we're not missing a key cohort from our particular survey or sample group. We want to make sure there's no transcription errors. That means that we aren't capturing correctly what people intended in their survey. We want to make sure there is no bias in the instrument itself, in the design of our questionnaire or the measurement method we're using. And we want to make sure there is no bias created consciously or unconsciously where the interviewer is influencing the responses. And we want to make sure that that we don't have any errors because we are not clear on the research objectives, what we're trying to accomplish, and how this is going to translate into a decision for the organization. So coming back to that problem definition that we talked about in some of the earlier videos, to make sure there's alignment between the information that's collected that will lead to action that actually will inform the organization related to a problem or opportunity that they are investigating.